Hi Zena, all good?
Yes, sir. Good evening, sir.
Oh, good evening. Did you attempt the homework or assignment?
No, sir, not the. No, wait. Yes, I did the assignment and the assessment.
Okay. Why not?
Mm. No, sir, I did it. I think I
Oh, you
submitted
did
it
it.
too.
Okay,
Yes,
okay,
sir.
okay. Yeah. Any doubts you have?
No, sir.
No. Okay. So let's wait few minutes, okay? Till then, please revise whatever we did in the last class, okay?
Yes, sir.
Yeah. Hi Rishita,
Good evening, sir.
good evening. Any doubts on the last class from the homework or assessment?
No, sir.
So let's start today's topic, that is transpose of a matrix. Just a second. Transpose of a matrix. Okay, what do we mean by transpose of a matrix? Write down the definition, that if A equals to Aij m by n matrix, then the matrix obtained by interchanging the rows and columns of A is called transpose of A. Okay, that is, if A equals to Aij m cross n, then A transpose is equals to AJI and N cross N. Okay, you just interchange the rows and columns. Write it down. I'll give you an example. Done?
Yes, sir.
Yes.
Okay. So what I mean by this, suppose A is equals to 1, 2, 3, and 4, 5, and 6. Okay. So A transpose will be just write this row into columns 1, 2, 3, and then second row becomes second column. Okay. Very easy. Yes or no?
Yes, sir.
So write down properties of transpose. What are the few properties of transpose? First one, that A transpose of transpose. What will this happen? A transpose of transpose?
It should be A.
Same
Yes,
thing. A.
absolutely. Very good. So if you transpose it 2 times, then automatically it will become this same matrix, right? Second one, suppose we have a constant multiplied with it, then it becomes, you can take it outside also, right? Constant has no role in like when you make transpose of a matrix. If you subtract or add and then take transpose, that is equals to A transpose, then plus minus B transpose. Okay, same thing. But remember this fourth one, it's very important that if you take AB transpose, okay, you are multiplying, then taking transpose of a matrix, then this is equals to B transpose A transpose. You have to change the order. All right.
Yes, sir.
Okay. Please note it down. Okay. One question. Question says if A equals to 3 root 3 and 2, 4, 2 and 0, and B equals to 2 minus 1 and 2, 1, 2 and 4, verify that A transpose of transpose is A plus B transpose is equals to A transpose plus B transpose. Third one, that A times B transpose is equals to KB transpose. Okay, K is a constant. Please solve this. You can do this, Zaina and Rishida.
Yes, sir.
Yes, sir.
Okay.
So,
Yes.
for the third bit, to prove KB whole transpose is equal to KP transpose. For this, do we only have to multiply K with B and then take out the transpose and then check whether the value is equal to K into B transpose?
Yes. Solve it using LHS and RHS, right? Just try to find LHS, then find RHS. You will see that both are equal. So you can say LHS is equal to RHS. So it is proved. Okay. Okay, I think the first two you can prove very easily. Let me prove the third one, which is LHS is KB transpose. Okay. So K times we need to multiply with 2 minus 1, 2, 1, 2, and 4, and transpose of this. Okay. So this is 2K minus K, 2K, K, 2K, and 4K, and transpose of this. Okay, Zara? Rishita, completed?
Yes, sir.
Okay. So this is the LHS. RHS we need to find K times B transpose. Okay. So RHS is K times 2 minus 1, 2, 1, 2, 4 transpose. So this is 2 minus 1, 2, 1, 2, and 4. And then we can multiply. So obviously we'll get the same thing. Okay. So LHS is equal to RHS, hence proved. Let's solve another question. It's saying if A equals to minus 2, 4, and 5, and B is 1, 3, and minus 6, verify that AB transpose is equals to B transpose A transpose. Okay.
Yes, sir.
Here also you have to do LHS and RHS, right? Two things you have to find. Okay, so now you have multiplied two things. Very good. If this is the speed, so LHS is AB transpose. So -2, 4, and 5 multiplied by 1, 3, and -6, and transpose of this. So this is 3 by 1 matrix, and this is 1 by 3 matrix. So the resultant will have 3 by 3 matrix. So 9 elements will be there. So first row, first column -2, first row, second column -6, then this 12, then 4, 12, and -24, 5, 15, and -30, and transpose of this. So it is -2, -6, 12, 4, 12, -24, 5, 15, and -30. Okay. Now we need B transpose, A transpose. B transpose will be 1, 3, -6. B transpose is 1, 3, -6. And A transpose will be equal to -2, 4, 5. We need to multiply these two. So RHS we have B transpose, A transpose, which is 1, 3, -6 multiplied by -2, 4, and 5. Here also similar thing. Will have 9 elements. So -2 and 4 and 5, -6, 12, 15, 12, -24, and -30. Okay. So we can see that RHS and LHS are equal. Okay. So hence proved. Nothing much difficult. Rishita, clear?
Yes, sir. I got the same thing.
Yeah. Matrix is very easy, right? So it becomes a little bit boring also, like because nothing to do a lot. Let's start a new topic, which is symmetric and skew symmetric matrix. Okay, symmetric and skew symmetric matrix. Write down the definition. A square matrix A equals to Aij is said to be symmetric if A transpose is equals to A, that is Aij is equals to Aji for all possible values of I and J. Okay, that means if you take transpose also, it will be same. Okay. For
Yes,
an
sir.
example, if I give A as suppose 1, 2, 3, 1, 2, 3, let's not give 4, 5, 5, and 6. Okay. So if you find transpose of this, you can see it will be 1, 2, 3, 2, 4, 5, and 3, 5, 6. Same thing. So A matrix is symmetric, then it will be equal to its transpose. Okay. Completed.
Yes, sir.
Skew symmetric matrix. A square matrix A equals to Aij is said to be skew symmetric matrix if A dash equals to minus A, that is Aj is equal to negative of Aij. If you transpose it, you will get a negative A matrix. Okay. This implies that we can say that write it down, then I'll explain what I mean by this. Okay, just write it down. Okay. So take this scenario that if I equals to j, where I is equals to j, these are the diagonal elements. You guys remember this? Suppose this is A, B, C, D, E, F, G, E, H. Then this row, like this, it is called the diagonal elements. Yes? Zena, Rishita.
Yes, sir.
Yes, sir.
Okay. So if I equals to j, then by this statement, we can say that aii equals to negative of aii, or we can say 2aii is equal to 0, or we can say aii must be equal to 0. That means all the diagonal elements must be 0. Okay, all the diagonal elements must be 0. Where? In skew symmetric matrix. Okay, so there is no skew symmetric matrix where the diagonal element is not 0. So if I have to give an example of skew symmetric matrix, it should be like this: 0, 1, 2, then -1, -2, then 0. Suppose this is 3 and -3 and 0. Okay. So if you look at this,
Sir,
and yes,
only the main diagonal will always be 0.
there is no main diagonal and like side diagonal, right? There is only one diagonal. Okay, in matrix.
Oh, but we can
Yes, you can make a
we can
diagonal like this, but it is not called the diagonal of a matrix. Okay, there is only one diagonal. Okay, remember this: diagonal of a matrix is not defined as like the theta side. No, it is defined where I equals to j.
okay.
Okay,
Okay.
so if you look at this, this is a11, but this is a13. So here I is not equal to j. Okay, so matrix has one diagonal. Now if we take transpose, then this becomes 0, 1 and 2, -1, 0 and -3, -2, 3 and 0. Right. If we take negative out, then it becomes -1 times 0, 1, 2, -1, 0, -3, -2, 3 and 0. So you can see this is equal to this. Okay, so negative of A transpose is equal to A. Hence, it is a skew symmetric matrix. Okay, and it's
Yes,
very
sir.
important. Okay, note it down. Done?
Yes, sir.
Okay. So few theorems we have which are extremely important for the board's angle. Just give me 1 second. Okay. Hi, Aftab. Aftab, your class is after 45 minutes. Okay. So please join after 45 minutes.
Okay.
Yeah. Okay. So what was important? Remember this theorem 1. A plus A transpose is always a symmetric matrix. Okay. Theorem 2. A minus A transpose is always a skew symmetric matrix. Okay. Note it down. And theorem 3 is we have any matrix or any square matrix can be expressed as the sum of a symmetric and skew symmetric matrix. Okay. Any matrix in this world, any square matrix in this world can be expressed as the sum of a symmetric and skew symmetric matrix. What I mean by this is, suppose I write A equals to or A plus A transpose plus A minus A transpose. So you can see that A transpose and negative of A transpose is cancelled. So what we have is half of 2A. So if we take half of this and half of this, that means half of A plus half of A is equals to A. And we already have known that A plus A transpose is always a symmetric matrix and A minus A transpose is always a skew symmetric matrix. So what I mean by this is A can be expressed in the form of this. जो भी मैंने कहा समझ में आया और not at all?
Understood, sir.
Okay, Rishita.
Yes, sir.
Okay, let's see the proof. Have you written this down?
Yes, sir.
1 minute, sir.
Okay. Okay. So first verify this. Suppose I give you A is equals to 1, 2, 3, 4, 5, 6, 7, 8, and 9. Please find A plus A transpose and then find A minus A transpose. Okay.
So are we only supposed to solve it, or are we supposed to express it as sum of a symmetric and skew
No,
symmetric
no,
matrix?
just find these things. Okay, A plus A transpose and A minus A transpose.
Yes, sir. Done, sir.
Okay, so if A is this, A transpose is this. If we add them up, we'll get 2, 6, 10. This is 6, 10, 16. Sorry, 14. This is 10, 14, and 9, 9 is 18. Okay, so you can clearly see that this is a symmetric matrix, and if you subtract them, what you'll get 0 and minus 2 and minus 4. This is 2, 0 and minus 2, minus 4, 8 times, and this is 6. So 2, and this is 0. So here also you can clearly see that this is a skew symmetric matrix, right? So this fact is established that A plus A transpose is always a symmetric matrix. A minus A transpose is always a skew symmetric matrix. Now what you do, please find half of this and half of this and add them up. Okay, multiply half and half on both the matrix, then add it up. Let's say this matrix
Would
was
that
called
be plus 4 in A minus A transpose?
plus 4. Did I make a mistake? Yes, this is plus 4. Very good. 7 minus 3 is plus 4. Okay, let's say this is B matrix and this is C matrix. So please find half of B plus half of C. Okay. So half of this will be 1, 3, 5, 3, 5, 7, 5, 7, 9. And half of this will be 0, minus 1, minus 2, 1, 0, minus 1, 2, 1, and 0. And then if we add them up, half of B plus half of C is equals to 1 plus 0 is 1, 3 minus 1 is 2, 5 minus 2 is 3, 3 plus 1 is 4, 5 plus 0 is 5, 7 minus 1 is 6, 5 plus 2 is 7, 7 plus 1 is 8, 9 plus 0 is 9. So you can see this is back to the A matrix. Okay. So hence we can see that we have expressed A as sum of two symmetric and skew symmetric matrix. Is it clear how to do this?
Yes, sir.
Yes, sir.
Okay. So always do this step by step. Let me give you a question. Remember, in boards, steps are extremely important. So always write steps. Okay. Do not skip any step. 2, minus 2, minus 4, minus 1, 3 and 4, 1, minus 2 and minus 3. The question is express the matrix B as the sum of a symmetric and a skew symmetric matrix. Okay. Okay, Zena. Rishita, completed?
Yes, sir.
Okay. Okay. Zena, what is the symmetric matrix you got?
Um, 2 minus 3 by 2 minus 3 by 2 minus 3 by 2, 3, 1 minus 3 by 2 minus 1 minus 3.
That should be 1 and minus 3. Last one, okay? Please check it.
Okay.
Okay. And Rishita, what about this Q symmetric matrix?
Sir, I didn't get anything close to that.
You didn't get anything close to that. Okay, let me solve this. What did you get, Rishita?
I got all positives, and it's not, it's above 10 somehow. Some of
About
them are
10.
about 10.
Okay, let's see. B transposes 2 minus 2 minus 4 minus 1 3 and 4 1 minus 1 minus 3. Okay, so let's add them. I'm writing here. Okay, you don't do this, you take space and write clearly. I need the matrices, so I'm writing like this. So B plus B transpose will be 2 plus 2 4 and minus 2 minus 1 minus 3 minus 4 and 1 is minus 4, sorry, minus 3, and this is minus 3 6 2 minus 3 2 and minus 6. Okay, so when you divide by half, so half of, let's call this P matrix, so half of P will be 2 minus 3 by 2 minus 3 by 2 minus 3 by 2 3 1 minus 3 by 2 1 and minus 3. Okay, Rishita.
Yes, sir.
And when we subtract B minus B transpose, let's call this matrix C, and B minus B transpose will be 2 minus 2 0 and minus 2 plus 1 is minus 1. So 0 and minus 1. 1 plus 3 by 2. So it will be 7 by 2. Oh, did I do some mistake here? This is B transpose. 4 minus 1 and minus 5 is minus 5. And then we have minus 1 plus 2. So 1, 3 plus 3 is 6. So minus 3 minus 3 is 0. 4 plus 2 is 6. 0 and 6. And here 1 plus 4, 5 minus 6 and 0. 5 minus 6 and 0. Okay. Zena got this as the matrix, second matrix. You just multiply by
Yes,
half.
sir.
Okay. So when you multiply by half, you'll have 0, minus 1 by 2, minus 5 by 2, 1 by 2, 0, 3, 5 by 2, minus 3 and 0. Okay, Rishita. Suppose this is matrix
Yes, sir.
D. So now if you add this C and D, you will see that you get the same matrix back. Okay. All clear?
Yes, sir.
One more question. E is
Sir,
equals to
how is
cos
that
alpha.
minus 3?
Oh, sorry,
How is this minus 3?
did I do any mistake?
No,
B, see, minus 2 and minus 4 is minus 6. So minus 6 by 2 is minus 3. Okay.
Okay.
So one more question. Cos alpha, sin alpha, minus sin alpha, and cos alpha. They're saying verify that A transpose times A is identity matrix. Okay. Okay. So here A transpose is cos alpha, sin alpha, minus sin alpha, and cos alpha. Okay. If we multiply this A transpose times A, so cos alpha and cos alpha, cos square alpha, and plus sin square alpha, then cos alpha and sin alpha, and minus sin alpha, cos alpha. Okay. Then cos alpha, sorry, sin alpha and cos alpha, plus sin square alpha. You did this sin alpha, cos minus cos alpha, sin alpha, then sin square alpha plus cos square alpha. Okay. This is 1, this is cancelled out 0, this is cancelled out 0, and this is again 1. So this is a identity matrix. Okay. Rishita, clear?
Yes, sir.
Let's solve one more question. If we have, if A equals to cos alpha minus sin alpha and cos alpha, and they are saying, and A plus A transpose is equals to I, then value of alpha is dash. Okay. Please solve this and give me 2 minutes. I'll be back in 2 minutes. Okay, guys?
Yes, sir.
Yes, sir.
What anyone?
Yes, sir. Sir, these alpha values, should we write them in degrees or radian?
Radians.
Okay.
Okay, in 12th we'll not use degrees anywhere. Everything is radians.
Okay.
So if we add them up, A plus A transpose, it will be 2 cos alpha and 0 and 0 and 2 cos alpha. It is identity, that means 1, 0, 0, 1. So that means 2 cos alpha is 1. So cos alpha is 1 by 2. And the options were pi by 6, pi by 4, pi by 3. So where does cos become half? Cos is half at
Pi by 3.
pi by 3. Right, Rishita?
Yes, sir.
Okay. One more question. Find half of A plus A inverse or A transpose and half of A minus A transpose when A is equal to 0 A B minus A 0 C 0 A B minus A 0 C minus P minus C and 0. Okay? Please solve this. Very easy question. Okay. Rishita completed?
Yes, sir.
Okay. So please go through the class topics that we covered today. Ask me if you have any doubts. You have 5 minutes. Okay, just cover the basics.